Hello everyone, we're going to talk about the advanced exposure technology. Exposure equipment in the old generation used the eyeliner and became paper. Nowadays we use the scanner exposure equipment, just as we talked about before. And the resolution equal this formula, and this formula NA equal this. So this formula is our exposure resolution. The number is small is better. We also talked about it before, and we know that this lambda decreasing smaller is better. In lambda is wavelength, the light or beam wavelength. We talked about it before also. Now according to Snell's law, this equation, this is the material 1 and the material 2 and the lambda 1, lambda 2. We talked about it before also. So that it means that the beam through the material 1, the light beam through material 1, the N1 means its material's refractive index, and the lambda 1 is the light beam wavelength, and the light beam go through the material 2. It changed its refractive index N2, and the light beam wavelength changed to the lambda 2. That's its meaning, this equation meaning. Now we are going to see about this. This is the without immersion exposure scanner. The light beam through the lens and come to the subject surface. This is all in the air. Material 1 is air, so the light beam keep its N1 and lambda 1, and we want to make this lambda resolution equation. We want to the lambda be smaller, decreasing. We want to use this Snell's law. We want to let the lambda 2 smaller. We need to use the material N2 bigger. This N2 bigger. This N1 lambda 1 is in air. The lambda 2 will be smaller. That's what we want. So we add the immersion liquid between the lens and the subject. The immersion liquid, we use the lambda, the N2, and N2 is bigger than the N1. So we got the lambda 2 is smaller than lambda 1. So we had to achieve the goal, lambda 2 smaller. This is the light beam through the lens system and going into the immersion liquid material, and it has the bigger N2 value than the N1 value. So we make the light beam has lambda 1 wavelength become to smaller lambda 2 wavelengths, and we can increasing its resolution. This is a lambda 1 and N1 and lambda 1 area, and this is the N2 lambda 2 area. It has smaller and shorter wavelengths to a subject. So you know that if we use the bigger lambda 2 than lambda 1, we get the smaller we get the bigger N2 than N1. We get the smaller lambda 2 than lambda 1. For example, in air, lambda 1 is 193 nanometer, and the lambda 1 in air equal 1. And we use the material is N1 is N2 equal 1.4 immersion liquid. After calculus, I got the lambda 2 shorter to be 137 nanometer, smaller than lambda 1, 193. So we put into the resolution formula. We got a better resolution. Use the lambda 2. That's the immersion exposure principle. Okay, let's see you next time.